Hi, this is a review for AP Physics 1 Momentum, Unit 5. The momentum is given by the letter P, which is a vector, mass times velocity. The velocity would be the vector. So you need to really keep in mind the sign of the velocities, positives and negative, which plays a very important role here. So the momentum is basically any object that has a mass and a velocity. It's the quantity that the object will possess. And if there is no external force to the system, it's always momentum is conserved. So we write it as P sub I equals P final. So it's conserved. And also, if we are dealing with two-dimensional momentums, like in X and Y axis, the problems that you guys will solve will be like trying to write momentum in each dimension, and you're going to write your conservation in each dimension. For this example, if you would see M1, it is moving horizontally. M2, it's vertically moving up, and then they collide together, they stick together, and they go at an angle. To solve this problem, if you see that initial momentum before the collision, in the x for this M1 is we have some initial momentum, whereas in the initially the y momentum is what we have for this, and there is no x direction momentum for M2. Same way, there is no y momentum for this object, so I put it as 0. However, we said it's sticking together. So you sum your masses and you have one final VF velocity. Since it's going at an angle, like we always want to split into vectors, so we can write it as VF cosine theta for your x factor and VF sine theta for your y. So and then you can equate your PX initial to PX final, PY initial to PY final, and you go in that route to solve this problem. Next, impulse. Impulse is basically change in momentum represented by the letter J, and it's given by force times time. Or the other formula we use would be m times delta V. So that is basically definition wise, force acting for a certain time to change the velocity is your impulse. And keep in mind, we will have Newton's third law, which means, let's say there's a car coming this way and truck hitting, there's a collision, and then they stick together and go. So if you would calculate the impulse, like in problems, the impulse of car on truck would be equal to the impulse of truck on car, except that they will be in opposite direction, which means if you would see here, the car will have a force coming this way, the impulse, and the truck will have the same magnitude in the opposite direction. So if they ask you a problem, you don't have to solve them both. You solve one and change the sign from positive to negative or negative to positive to find the impulse of the other. The next common question that you will see on an impulse is graph question. If they give you force versus time, the area under the curve would be your impulse. So just like any area under the curve, that would be positive value and that would be a negative value. And we can equate the impulse to either if you want to solve m delta V, and then sometimes they give you your initial velocity is given and they ask you for the V final. So we use the number from this. You equate it to like the kinetic energy, or like the 1/2 mv f square minus, and you can plug back the impulse value, the change in momentum. No, sorry, not the kinetic energy, sorry. So it is going to be like J equals m V final minus V initial. So if you're given the V initial, if we know the impulse from the area under the curve and we know the mass, we can find the unknown V final. That's a very common impulse graph question that you will see. Okay, next we talk about collision. The first type of collision is elastic collision. So all the collisions that we will discuss in this unit is going to be like all momentum is conserved for all types of collision. However, kinetic energy is only conserved in elastic collision. Some tips to know: if the masses are the same and they approach with different velocities, after the collision, they would swap their velocities just to have conservation of energy. So just keep in mind. And if the one of the big mass is very massive and the other is like very lighter, and this collision will have no impact on the velocity of the bigger mass. That makes sense. Let's say if two objects have the same momentum, they approach each other, where the P net is 0, which means they come to a complete stop. And this is a very important equation velocity approach equals velocity separate, this could only be used for elastic collision. Sometimes you will be asked to find, when you're writing the momentum equation, you will have two unknown like V1 final and V2 final when you write your equation. So in that case, you're going to use this situation where you will have a U1 minus U2 that will be given from the problem, which means your initial, you know them. You will have a number for this, and you can write this as basically when you say V2 final and V1 final, you can write one in the form of the other, and we can substitute in the momentum equation and we can solve one, and then once you solve one, you plug back that into to find the other one. So whenever you have two unknowns in your elastic collision problems, this is the thing you will use. This is actually coming from kinetic energy and momentum equation combined systems of equation. You won't have time to derive all those in the exam, but just keep this in mind to use it for calculating the two unknowns in an elastic collision. That mind it, it's just only for elastic collisions. All right, the next type of collision is inelastic and perfectly inelastic collisions. Both the collisions, the momentums are conserved. However, the kinetic energy is not conserved. When this inelastic collision happens, they both travel with two separate final velocity. They have their own. However, perfectly inelastic is when the object collide and they stick or couple together and they act like as one mass. So usually sum the masses and they travel with one final velocity. And keep in mind, again, kinetic energy is not conserved. Always the kinetic energy initial is going to be greater than final, because you lose some energy when the collisions happen. So usually the kinetic energy goes down in these problems. So usually you'll be asked for the energy loss and stuff. So you calculate the initial, final. You always do final minus initial. So you'll get a negative value that tells you that it's decreased. Okay, the next topic is going to be a little bit on center of mass. So when you have two objects like in a system, if they are the same mass, the center of mass would be like equidistant, like in the middle. Okay, so if you have two masses which are, one is massive, the center of mass is going to be lying, because what is center of mass is basically the mass of the object that is kind of like concentrated at one point. If it's a massive one, the center of mass is going to be closer to that mass. So let's say if it's 0.8 and we call this x distance, it's 0.8 minus x. So if you want to set up a ratio, it is going to be in the ratio of 5 to 2, like when you do like the math. So it's going to be x over 0.8 minus x equals 5 over 2. And keep in mind that if you have a force net, like means a net force on the system is 0, there's no external force, which brings us to acceleration as 0. So keeps your v in constant. Because v is constant, there is no change in velocity, no impulse, momentum is going to be constant. Okay. And explosion problems, when you have explosions like these pieces, like the forces between them, they push each other, but they are equal and opposite in magnitude, so they cancel out each other. So there is no force involved, which means P is going to be constant because F net is 0. And also keep in mind, if there is no external force, if they ever ask you, the velocity of the center of mass is also going to remain constant. Just for physics 1, just keep this in mind. If there is no external force, the velocity of the center of mass is not going to change. It's going to remain constant. The next thing I want to discuss about is going to be like a spring block system where you relate conservation of energy to find something. So first, initially, they ask you for final velocities. You would just like do the momentum conservation equations and do it. The majority of this thing I want to talk about is how we use spring energy in it. So keep in mind the spring will have spring potential energy 1/2 kx square only when it is compressed. Okay, so when it's relaxed or like stretched back, there is no, because it is that energy is given to move the block, which means that it's converted to kinetic energy. So once it's released, so this is only present in the compressed situation. So when you are writing the block's energy equation during compression, you could write kinetic energy for the block 1 and 2 and also use the spring energy for that. But before the collision, the spring energy will not have anything because it is not compressed. Keep that in mind. And another thing to do on this problem is When they ask you to find like the compression, how far it's compressed, we use this like the x distance, right? Like to calculate the how far it's compressed. There's also a situation they sometimes ask you calculate the maximum compression. So when you do this, keep in mind during the maximum compression of a spring block system, the blocks, both of the blocks will have a same velocity. So when you write your momentum equation, you are going to assign the same variable for the velocities of these blocks, and you still write your energy equation, and still you will solve for x. The main difference between to find compression versus maximum compression, for maximum compression you're going to include both the blocks with same velocity. Hope this helps.